So our model is almost completely finished. Rainfall is almost done. So it just needs a bit of more time to drain, but we definitely have enough information to review this project and to do some mapping. So I'm going to shut it down here and we'll let it finish and we'll start looking at some of the results and maps on this project. Okay, so let's minimize some data that we're not using and let's create a new group called results. And I'm going to pop this dude down here and then I'm going to click save. Okay, and the data that goes into results, we may not want to save it into the geo package, so that's why I clicked save. So we might just want to, and sometimes you want to do your review in a different project than in your QGIS project, but that won't hurt anything to do it here. So this should be done, so let's click close and let's take a look at some of the data and some of the ways that you can map this data. So if you use the Rasterizor tool, that's Flow 2D Rasterizer, you can like rasterize loads of different kinds of data. So a lot of these output files, so I think we just want just .out files, honestly. So a lot of these output files are mappable, but they have to have a certain format. So let's take a look at this depth or let's just look at depth.out and let's name it max depth. And let's put it in this output directory. We're going to put it in here, but we're going to call this, we're going to put it in a folder called maps. Okay. And it is a depth. And I click run, and that added that layer into my results group. Now let's take a quick look at that file and kind of what format it has to be in order to use it with Rasterizor. So we did depth. We did this one. And so you can see that it has grid element number, x coordinate, y coordinate, and the variable that we're plotting. And it just rasterizes it. So we can get depth.out and let's get final depth.out. So let's hit F and final depth.out is the one we want. And we'll call this one final depth. But we didn't really let it drain, so I don't know that they're going to be a whole lot different from one another, to be honest with you. And then let's run that one, and then you see we added the final depth. And let's get water surface elevation. That would be max water surface elevation. So let's grab that one, and that's M, max water surface elevation. That is a maximum water surface elevation, so max WSELEV, and it's not a depth, it's an elevation, so do that. And we don't really need to see that one, so we can just turn it off. And now we can click one more, and that is comparing the output. So we can compare the, well, we want to compare the maximum depth to the final depth, because those are the only two that are comparable. And this becomes max minus final, because the maximum is the first file, and this goes to maps. And we run that to run. Okay, and now we're finished with Rasterizor, so we just close it. Okay, so let's take a look at some of this data and just how it is plotted. Okay, so let's just go to our maximum depth and let's turn off our grid and double click it, and let's just set this minimum value to 0.1, and that says clip out of range values. Click apply, and that will click anything out that's like less than 0.1 foot of depth. So it kind of helps you see things a little better, get a better idea of how the water is moving. You're going to notice a couple things right off the bat, like there is water trapped right here by that basin because the project doesn't extend far enough over to that basin. So maybe a good idea to put an outflow node right there. Our maximum depths in our channel, the water is deeper there, so that's good. We have water stuck in this basin because we are missing a big culvert and a storm drain right here. So that's interesting. The difference of the final, this is blue is, the final is, I mean there shouldn't be any blue really. Let's do that. Okay. Let's do this. Double click on that. And the color differences are 0, and then we can make that one opaque too, because it's clearly just 0. So the color differences are, if it's blue, the differences are negative. That means the max is lower than the final. And if the differences are red, that means the max is higher than the final. And that's only happening in the channel. And of course, this is a terrible difference analysis because the we didn't run the simulation long enough to allow the system to drain, and so that's why our colors don't make any sense. So I just wanted to show you that the tool works and let you see it. So we'll ignore it, just let you know that it works. I don't know why this thing keeps going and sticking in that. I think it's because I'm doing the video. Water surface elevation. Now let's take a quick look at one thing you can do with another plugin called the interpolation tool. So I am going to shut these two off, and I'm going to add this layer here, and then I'm going to add our elevation layer here. And then I'm going to expand this window so that I can turn this one to blue and this one to black. And then I will draw a profile, some spot where there will be a difference. So you can see here that that's our maximum water surface elevation in this basin. And then that is our maximum water surface elevation in this basin. So you can tell pretty clearly that this basin is not draining into this basin. Here is our maximum water surface elevation here. You can tell that is the end of our project. And this is filling up and not able to spill out. Let's see what it looks like in a channel. It's okay. Anyway, so that's your profile tool. Okay, let's change gears and start looking at some results from the map. So this is set to already our export folder. So what we can do now is we can use some of these results tools. So let's turn our schema layers back on, and let's use this result viewer to start looking at some of this data. So if I click this hydraulic structure, hang on, I gotta put the tables back on. I gotta put the flow duty table and plot back on. Okay. And if I click on that structure, oh, gotta get it back on there probably. Then it should load the results in here. Let's try it again. Yeah, there we go. So that is the discharge result for the hydraulic structure. Remember, we used that stepped hydrograph to test our rating table, and that is the discharge through that structure. Okay, same thing here, same thing, except of course it's delayed because of the delay in time of travel time. You can also pick up initial hydro cross sections, and you can get the this is a little, I have a feeling I'm on a slightly older plugin because these little eyes are not supposed to be there. But if you click on this, you can choose what you're looking at. Depth, velocity, that's the calculated FRUD. As you can see, it's nowhere near supercritical in that particular cross section. Flow area, wetted perimeter, hydraulic radius, top width, width to depth ratio, energy slope, shear stress, and the surface area. So you can plot all of those variables. Let's see, I think that's it, because that's the only thing we have in this. We don't have anything else in this to plot. So if I click over here, so that's the only thing we can plot. And of course, if you ran a time-dependent run, you'd be able to animate the data on the map. But we haven't done that yet, so that's more detail than what we have. So that's how but you can use these tools to help you review. Say, what am I looking for? I'm looking for the discharge to be realistic down from this cross section. And it is. There's no spikes. It's not going unstable. The velocities are realistic. It makes sense. The discharge values don't go above 450, except for you do have some rainfall, so they do go above 550 because the rainfall is in addition to it. So that's kind of what we're looking for. And that's basically it for this video. So I'm going to shut the video down and post this to this final video of this lesson. But don't forget that you also have the 115. All this information is also in the 115 video.